Moving on to our next question, which is question number 10. So in question number 10, we are given three identical rigid circular cylinders, A, B, and C. Suppose this is cylinder number 1, suppose this is cylinder number 2, and supposingly this is cylinder number 3. Let us draw this cylinder number 3 once again. So these are the three cylinders, A, B, and C. Now they are kept in such a way as shown in the diagram. There is an inclined plane here on B, and there is an inclined plane towards A. Suppose the angle of inclination here is theta. So this angle here is theta. And this angle here is also theta. Now, in this case, we have to find the least value of theta, that is theta minimum, so that this arrangement does not collapse. Now, for the arrangement to not collapse, these three spheres or these three cylinders must be in equilibrium. So let us consider the free body diagram of C first. So suppose I consider cylinder number C. This is cylinder C. Let us see what are the forces acting on cylinder C. So one force is as shown. It is the normal reaction of cylinder A on cylinder C. Another is normal reaction of cylinder B on cylinder C. So let us call this normal reaction as, suppose we call this by symbol N1. So this is N1. Now the weight of the cylinder will act in downward direction. So this is the weight of the cylinder mg in downward direction. Now let us shift these normal reactions N1 parallel to itself. So this is normal reaction N1 on extending, and this is also normal reaction N1 on extending. So now let us think about the components of N1. This is N1, this is N1. And if I draw the components of N1, it will be like this. The vertical component and the horizontal component. So suppose these are the components of this N1 force. So now let us think about the angle. What will be this angle? So because in this case we have an equilateral triangle when we join the centers like this. So if I join the centers of these three spheres, it will be an equilateral triangle. So this angle here will be of course 30 degrees. Because this total angle is 60 degrees as it is equilateral triangle. So if I extend this further with the vertical, each of the angle will be 30 degrees as shown. So this angle is 30, this angle is also 30. Let me show it in better diagram. This is our sphere C, which we have here. And if I extend this, this will be the extension. And here, this will be the extension. So this angle here is 60 degrees. Now with the vertical, of course, what will be the angle? With the vertical, it will be 30 each. That is the 30 angle which we are showing here. Okay. So now after this, let us take the components. So this will be N1 cos 30 for each of N1. So 2 times N1 cos 30 because we have 2 N1s here. So what will be the component? 2 times N1 cos 30. This is the component. And this N1 sin 30 here and N1 sin 30 here, they will cancel out. So these N1 sin 30 cancels out. So what we are left with is 2 times N1 cos 30. 2 times N1 cos 30. This equals mg. So upward force is equal to downward force. So we can say 2 times n1 cos 30 is equal to mg, which gives us n1 is equal to mg upon 2 times cos 30, which on calculation comes out to be mg upon root 3. So the value which we'll get here is mg upon root 3. So n1 comes out to be mg upon root 3. Now, let us take the free body diagram of A. So for cylinder A, let us draw this cylinder A. This is cylinder A. Now let us think about the forces acting on A. Of course, one force will be by the surface. The surface will exert a force as shown. The surface exerts a force N1 as we have already seen. Other than that, let us think about other forces. One is weight. The weight of this block acts in downward direction, and it is of course mg. Weight of block is mg. Then let us think about the other forces acting here. So other forces acting here will be N2, the normal reaction. So see here N1 is normal reaction by A on C. This is N1. Now what we are considering N2. So N2 is the normal reaction by C on A, by cylinder C on A. So let us see the direction of N2. So N2 will be something like this. So here we will have N2. Let me show it here. Slightly at some angle. So this is N2, normal reaction. Now I hope you have understood the normal reaction by C on A. Now let us think about the forces acting. So in this case, first of all, sorry, this is slightly wrong, which I did here. So first of all, in this case, what is N1 and N2? So N2 is the normal reaction, N1 is the normal reaction by C on A. So it will be like this. It will be like this, something like this. So this will be N1 actually. And N2 will be the normal reaction. Let me draw N2. This is N1. N2 will be the normal reaction by the inclined plane on the surface. By the inclined plane. Inclined plane is like this, so perpendicular, like this. This is how we have N2. So I hope you understood what is N2. N2 is normal reaction by incline on body A. So this is about N1 and N2. N1 is like this from C on A, and N2 is like this. Now, let us consider the forces acting. Weight is there. Now, if I take the components of this N2, so in this case, what will be the N2 component? So let me extend this N2 further. So N2 can be extended further like this, so that we can take its components. This is N2. And this is N2. So N2 will have two components. So if we consider the geometry, so by geometry, we can easily prove that this angle here with the vertical is theta. Once you get this theta here, so let us think about this component of N2. It will be N2 cos theta. And this horizontal component here will be N2 sin theta. So these are the components of N2, N2 cos theta and N2 sin theta. Now, after this, let us take the N1. So this is N1. So now if I think about the N1, So N1, this angle here, if I slightly extend here, like this. So in this case, we will have some components like this. So if I take this component, this component here will be N1 sine 30, and this vertical component will be, so in this case, this is N1 sine 30. Now, after this, let us think about the other forces. So we can say N2 sine theta, this horizontal components, they are equal. We can say N2 sine theta equals N1 sine 30. So from this, I can get N2 sine theta is equal to N1. What is the value of N1? Mg by root 3. Sine 30 is half. So we can say from this, N2 sine theta comes out to be Mg upon 2 root 3. So this is how we do. Then next consider N2 cos theta. That equals my force balance here. So we will have one component of this N2 cos theta. This will be equal to Mg plus another component of N1, which is in this case N1 cos 30. So vertically down component will be N1 cos 30. So this is the free Newton's law equation in vertical. So now after this, if I solve these two equations, so on solving these two equations, we'll try to get theta. How will we solve? Let us call this equation 1, let us call this equation 2. So now 1 divided by 2 gives us tan theta is equal to mg upon mg plus n1 cos 30. N1 value will substitute, this N1 value I'll substitute here. So N1 is mg by root 3 into cos 30 sine 60, which is root 3 by 2. So this root 3 cancels, and we get this answer here. So for tan theta, it will come out to be 1 by 3 root 3. So our answer to this question is 1 by 3 root 3. So the correct answer is option C for this question. So I hope you understood this question. Let us move on. You need to look closely at the geometry for this thing. So this angle on thinking, you will understand this is 30 and 30. So hence we have this component as 30. So then let us see next question, which is question number 11. So in question number 11 of our class notes, let us see. So we have a block which is placed on a horizontal plane, rough horizontal plane. Let me draw a rough horizontal plane. So this is the rough horizontal plane. And let us place a block here. We have a force which is F is kT. The force here is given as equation F is kT. K is positive constant. We have to find the acceleration time graph. Let us try to draw the acceleration time graph. So on x-axis we have time, y-axis we have acceleration. Let us try to draw the acceleration time graph. So first of all, how will the force time graph look like? So in this case, force is given as kT. Expression of force is kT. Rough horizontal plane, so there will be friction. So we can say in this case, friction will act in backward direction. Friction opposes motion. We have seen this. So friction will act in opposite direction. This is the direction of friction. Let us denote the friction by small f. So capital F, the big force, is supposed to consider the acceleration in right. So big force minus small force is mass into acceleration. Big force is capital F because the block is moving in the right direction. Minus small force is friction force is equal to mass into acceleration. So big force minus small force friction in this case is kinetic friction mu mg. So that equals mass into acceleration. So now from this, I can write the value of acceleration as F minus mu mg upon n. Let us put a box around this equation. So this is the value of acceleration. Now, once we got this acceleration, so F minus mu mg, this upon m, this is the acceleration. Let us try to draw the graph of acceleration versus time. So let us substitute the value of this F force here. If I write this F force as kT, because F is kT. If you see carefully, this comes out to be a straight line. So in this case, we have acceleration is coming out to be a straight line from this equation because ma is kT minus mu mg. So a acceleration is k by m into t minus mu g on dividing by m on both sides. So this is of the form y is mx plus c, where c is this constant which is negative intercept, negative y-intercept. The straight line will be something like this. Let me denote it in blue color, having a negative intercept like this. So the correct answer is option D. So the correct acceleration time graph for this question will be option D. So that is how we solve this question. Let us move on to our next question, which is 12th question. So in 12th question, we have a plumb bob, which is hung from the ceiling of a train compartment. So let us show a plumb bob. This is train compartment. This is the bob, like this. The train is moving on an inclined track. So we don't have the train like this. Let us redraw this diagram. We have first an inclined track. And on it, we will have a train. And these are the tires of the train. Now let us show this bob here. The bob will be vertical like this. This is the bob. And let us think the angle with the vertical it makes is something like theta. Let us show this angle theta here. This is that small angle theta. Okay. Now the question says acceleration of the train up. It is given as g by 2. The angle which the string makes. So we have to find theta in this case. So this theta value we have to find out. This theta, small angle theta. So this inclined plane angle is given as 30 degree. Let us see how to solve this question. So if I talk from ground frame, so if I'm in ground frame, I'll see that the bob has various forces. So one force on the bob is, so let us think about the forces acting. One force is mg in downward direction. Then we have the other force, which is in this case the tension force. So what will be the direction of tension force? So tension will be acting in along the string. So in this case, what will be the direction of tension? So mg acts vertically downward, and tension in the string will be slightly at some angle. Let us consider the angle. So as the bob accelerates, tension will be at some angle. Let us say this is tension force T. Other than this, what is the other force? So let us consider the pseudo force. So in this case, I consider this as, in this case, the pseudo force will be in this direction. So it will be mg by 2 into. So due to the acceleration of the train up the incline, we will have the tension. The string will be slightly tilted and tension will be at some angle. But mg force will act in downward direction itself. So let us now do some geometry. And by geometry, what we can find here is this angle here. So we want to find this angle. So this is mg component. So let us think about this angle first. So this angle here with the horizontal, it will be 30 degree because angle between two lines is angle between the perpendiculars. So this is mg by 2. This because this is pseudo force. This is pseudo force. Because the train is accelerating up, there will be a pseudo force mg by 2 down the incline. So this is mg by 2 pseudo force down the incline. Its component along horizontal will be mg by 2 cos of 30. So this is mg by 2 cos of 30. And now let us do some geometry. So if I take this angle further, so this angle here will be 90 minus theta and this will be 30 degree. This will be 30, this is 90 minus theta. So this angle will, total angle will be 120 minus theta because it is 90 minus theta plus 30. So this component of tension will be T cos of 120 minus theta and this component will be T sine of 120 minus theta. So like this we have geometry here. So how do we get this angles? You can easily get this. This angle here is 30. So this angle is 30 itself, vertically opposite angle. And why is this 90 minus theta? Because this is theta angle. So we can do geometry and we can find that this angle will come out to be 90 minus theta. So total angle is 120 minus theta. So here what will be first law equation in horizontal, Newton's law equation. So T cos of 120 minus theta, it will come out to be, in this case, mg by 2 cos 30. This is horizontal Newton's law equation. Vertical Newton's law equation will be mg plus component of this mg by 2, which is mg by 2 sine 30. So mg plus mg by 2 sine 30, it will be equal to t sine of 120 minus theta. So now if I divide these two equations, horizontal and vertical, t and t will cancel and we will get tan of 120 minus theta. What are we doing? We are taking this vertical equation and dividing by horizontal equation. So we'll get tan of 120 minus theta. It will come out to be mg plus mg by 2 into sine of 30 upon mg by 2 cos of 30. So on dividing, we'll get equation which is 1 plus 1 by 2 into 1 by 2, 1 by 4 upon cos 30 sine 60 root 3 by 4. So root 3 by 4 in denominator. So 4 and 4 cancels, we'll get 5 by root 3. So tan of 120 minus theta comes out to be 5 by root 3. So from this we can get the value of theta. It will come out to be tan inverse of 2 by root 3. So the answer to this question is theta, which is tan inverse of 2 by root 3. So this is the final answer to this question. Theta is tan inverse of 2 by root 3. So I hope you understood this question. So in this case, the train is moving up the incline, so pseudo force acts down the incline direction. Then we have this bob and its tension T, mg, and other component which is pseudo force mg by 2. So it will resolve the forces along horizontal and vertical by geometry, and we will get this horizontal equation and vertical equation. So if I divide these two equations, horizontal and vertical equation, I will get vertical divided by horizontal gives tan of 120 minus theta, which comes out to be 5 by root 3. And by mathematics, theta comes out to be tan inverse of 2 by root 3. So the correct answer to this question is option B. So correct answer to question 12 is option B. So after this, let us move on to our next question, which is question number 13. So in question number 13, we have a lift. Let me show the lift here. And inside the lift, we have a man. And there is a pulley at the top. Something like this. So now one end of this is connected to the lift of mass capital M, and we have a man here whose mass is small m, and this man is holding one end of the rope. So now in this case, man is raising himself and the crate with acceleration this. So this is going up with acceleration of 5 meters per second square. Mass of the man, small m, it is given as 100 kg. Mass of crate, capital M, is given as 50 kg. In this case, we have to find the tension in the rope. So let us think about the free body diagram. So in this case, let us think one. So in this case, we have total weight, which is m plus m into g in downward direction. Then we have other force, one more thing, which is acceleration in upward direction. One tension force T in upward direction. So in this case, we have one more tension T. So the total tension on this system. So if I consider only this system, here, only this system, not the pulley. So if I consider this system here, so on it we have an external force which is 2T in upward direction and m plus m into g force in downward direction. So 2T force acts in upward direction on this man plus lift system. So that equals mass, total mass m plus m into acceleration. So our equation will be 2T minus 150g is equal to 150a. Let us substitute the value of a as 5. So our answers come out to be 2T minus 150g is equal to this. So on solving, we'll get P is equal to 1125 Newton. So this is the answer to first part of the question. So question 13, our answer is option B. Tension T comes out to be 1125 Newton. So how do we get this? Simply 115 5 we know it is, in this case it will come out to be 15 into 5. So tension comes out to be 1125 Newton. Then let us move on to next question, which is similar to this continuation of this question itself. In this case, we have to find the contact force between man and the crate. So let us try to find the contact force between the man and the crate. Now we are doing question 14. So let us think about the free body diagram of the man. So force is mg in downward direction. We have tension force T in upward direction. Normal reaction in upward direction. And acceleration, which is phi in upward direction. So in this case, for the man, we have T plus N, the upward forces, minus downward force mg is equal to mass of man into acceleration of man, which is phi. So we can write acceleration of man is a here. So N we have to find out. T we already found. It is coming out to be 1125 plus N we have to find minus mg, which is 100 into g, which is 1000. So that equals mass of man, which is in this case, how much is the mass of man? It is 100 itself, into acceleration is 5. So on solving, normal reaction will come out to be 375. So the correct answer to question 14 comes out to be 375 Newton. So this is the answer to 14th question. So I hope you understood both this question. Question 13, option is B, 1125 Newton. Question 14, answer is option B, which is 375 Newton. So let us move on to next question after this. Let us look at next question, which is question number 15. So in question number 15, we have a vessel at rest. Let me draw a vessel at rest. Suppose this is the vessel at rest. It explodes. So this vessel explodes by breaking into 3 pieces. Let us show one piece here, another piece somewhere here, and another piece somewhere here. 3 pieces. So all three have same speed, 30 meter per second. They have equal masses as well, m, and n. All three pieces have same masses. The third, no, they don't have same masses. Two have same masses. The third one has different mass. Let us show the third one having a different mass. 3 times the mass of other piece. So this is the third mass. This is the original mass, which is m plus m by m. It breaks into 3m, m, and n. So these are the three masses. Okay. And these three masses, it is given to us, they are equal perpendicular to each other. So this is 90, this is 90, and this is 90. So if the angles are 90, let us make a simpler diagram. Let us take them along the x, y, and z axis. Let us show x, y, and z axis, because that will make this some simpler. Like this. So in between we have the mass, total mass. The total mass, if you remember, it was phi n. Like this. Now, in this case, let us consider the velocities first. So 30 meter per second, 30 meter per second, and 30 meter per second. So if these masses here are, total mass is m, let us say. So this will break into three parts, 0.2 m. This is also 0.2 m. And this will be 0.6 m. Why? Because the third mass is 3 times the one mass. So if you think about this, how I got this, so suppose I consider entire mass as 10 m. So what will be the breakage? So 6 m, 2 m, and 2 m. So if I consider 1 m mass, 1 kg mass, so it will be 0.6, 0.2, and 0.2. This is how I got this. So this is the breakage of the mass. After that, let us think about the total mass in this case. So 0.6, 0.2, 0.2, and 0.6. This is the total mass, which is 1 m total mass. Now, if I consider the conservation of momentum along x direction, so what am I applying? Conservation of momentum. So in this case, what will conservation of momentum equation give us? So let us find the equation for conservation of momentum first. So in this question, we are given the two particles are moving perpendicular to each other. Let us consider these two particles. We have to find the velocity of the third particle. So let us consider this third particle. So it is moving in the same plane. These two are perpendicular and this is in the same xy plane. Suppose I consider this x-axis. Suppose I consider this y-axis. So this particle, third particle of mass 0.6 m, it is moving in the xy plane itself. So let us take the components of this velocity v. If I consider this angle as theta, then this component will be v cos theta, this component will be v sin theta. So if I apply conservation of momentum along x-axis, so conservation of momentum along x-axis will give us this equation. So we'll get 0.6 m, which is the mass of third particle, into its x velocity, x component of velocity, which is v cos theta. That equals 0.2 m, which is this 0.2 m mass, into its x component of velocity is 30. Then the conservation of momentum along y-axis, it will give me, the y-axis conservation of momentum is this, like this. So we will have 0.6 m into v sin theta, that equals 0.2 m into 30. Now, if I divide these two equations, if I divide, so 0.6 m, 0.6 m, v gets cancelled, 0.2 m, 0.2 m, 30, 30 gets cancelled, and we get dividing cot theta is 1. So theta comes out to be 45 degree. So what we find is this angle theta comes out to be 45 degree. So now if this is 45 degree, then this angle here will be 135 because it is supplementary angle, 135. So our answer will be, in this case, angle is 135 degree. Let us find the velocity v. So let us substitute the value of theta in this equation. So in x equation, 0.673 cos theta is equal to 0.2 m into 30. So we will have, in this case, mm cancels, and we will have 0.6 into v into cos of 45 is equal to 0.2 into 30, which is, in this case, it comes out to be 6. So from this, v upon root 2 comes out to be 6 upon 0.6, which is 60 upon 6, which comes out to be 10. So our answer comes out to be velocity v comes out to be 10 root 2. So our velocity v is 10 root 2. So the correct answer is option A. Velocity is 10 root 2 of the third particle. So v comes out to be 10 root 2. And angle it makes is 135 degree. So this is how we solve this question number 15. So once you understand this question number 15, let us move to a similar question, which is question number 16. So in question number 16, we have a radioactive nucleus. So suppose this is that radioactive nucleus. It is given that it is initially at rest. So this is initially at rest. It breaks off after it decays by emitting an electron and a neutron. So suppose this is the path of the electron and suppose this is the path of the neutron. These two paths are given to be at 90 degree according to the given question. So the momentum of electron, it is given to us as 3.2 into 10 raised to minus 23 kg meter per second. And the momentum of neutron, it is given to us as 6.4 into 10 raised to minus 23 kg meter per second. So this is the given information. The direction of recoiling nucleus with that of electron motion is. So recoiling nucleus will have this direction. Nucleus will recoil in this direction. So this is the direction of recoiling of nucleus. So we have to find, in this case, the angle. So let us try to solve this question. Let us find the, in this case, let us find, first of all, take this horizontal and let us call this angle as theta. So momentum of electron, we will have cos component, cos theta, and this will be 90 minus theta. So we will also have the momentum of neutron into cos of 90 minus theta. So momentum of electron cos theta plus momentum of neutron into sin theta. So this is the equation which. So if we try to get the equation in horizontal for conservation of momentum, we will have momentum of nucleus is equal to momentum of electron cos theta plus momentum of neutron sin theta. Now in vertical direction, if I consider in red color, so in vertical direction, we will have momentum of electron into sine of theta, and in vertical direction for neutron, we will have momentum of neutron into sine of 90 minus theta. So this is for the neutron, its vertical component. This is for the electron, its vertical component. So these two momentums will come out to be same. So momentum in vertical is equal for electron and neutron. So we will have our equation P sine theta is equal to Pn sine of 90 minus theta. So from this we have P sine theta is equal to Pn cos theta. So tan theta comes out to be Pn upon Pe. So Pn is 6.4 into 10 raised to minus 23 and P is 3.2 into 10 raised to minus 23. 10 raised to minus 23 cancels and we get theta is tan inverse of 2 because tan theta is in this case 2. So theta is tan inverse of 2. Now, according to given question, we have to find this angle. So this angle we are interested in finding. So this angle is pi minus theta. So our answer will be pi minus theta, which is pi minus tan inverse of 2. So the answer to this question comes out to be pi minus tan inverse of 2, which corresponds to option A. So the correct answer to question 16 is option A. Now, moving on to next question, which is question number 17. So in question number 17, we have a shell which is fired from a cannon. So from the cannon means we'll have a projectile motion. So it is projected at some angle, let us say B. Let us draw this diagram in a better way slightly. So a shell is projected from a cannonball. The velocity of cannonball is V, making an angle theta with the horizontal. So at the highest point, it explodes into two parts of equal masses. So if initial mass was m, then the final mass will be m by 2, m by 2. One of the masses retraces its path. So this mass, let us say, retraces its path. So we can say, what about the velocity of other mass, other piece? So how will we find? We will have conservation of momentum. So initial momentum along x direction is mass into v cos theta. So that equals final momentum of two pieces. So initial momentum mv cos theta is minus mv by 2 into cos theta. Why? Because this m by 2 mass, let me show this graph once again. So see what we have done here. Initial momentum equals final momentum. Initial momentum is mass of this into velocity v. This equals final momentum, which is m by 2 into its velocity plus m by 2 into its velocity. So one part, let us say it has a velocity v dash, let us say, and this has a velocity v. So in this case, we will have the horizontal component, it will be v cos theta, because the horizontal component of velocity does not change. So m by 2, this particle will have velocity as v cos theta, but in opposite direction. So this will be minus v cos theta. And this will have a velocity v dash in horizontal direction, let us see. So let us try to find the value of this v dash. Let us cancel m from both sides. So v is minus v cos theta by 2 plus v dash. So v dash comes out to be v plus v by 2 cos theta. So from this, we have one more 2 here, like this. So cross multiplying, we will get v dash by 2. If I cross multiply these two, I will get v dash by 2 is equal to 2v plus v cos theta upon 2. 2 cancels. And from this, we get the value of, so in this case, v dash also, we will have the component. Let us think about it. What will be the values? So options given are 3v cos theta. I take the cos component here, mv cos theta. So here I will have mv cos theta. So initial momentum we have in horizontal direction. We are applying conservation of momentum in horizontal direction. So because we are applying in horizontal direction, we will not have velocity v here. We will have the velocity component as v cos theta. So from this here we will have v cos theta. So here also we will have v cos theta. So here also we will have our equation as v dash by 2. From adding these two, we will have 3v cos theta upon 2. So 2 cancels and we get the value of v dash. It will come out to be 3v cos theta. So the correct answer to this question is option A. So what is option A? V dash is equal to 3v cos theta. So this is the correct answer to question number 17, option A. So I hope you understood. In this case, what did we do? Let us see once more. So we slightly messed up this the COTS component. Let us show this once more. So in question 17, we had a projectile like this. This is velocity v, this is angle theta. At highest point, it broke into two parts. Initial mass was m. So final mass of two parts will be m by 2 and n by 2 each. So initial momentum in x direction is mass m into velocity in x direction, which is v cos theta. So initial momentum in x direction, it is pi x is equal to p final x. So pi x comes out to be m into v cos theta, and pfx final part. So one velocity here, it will come out to be, in this case, it retraces the path. So its velocity will be m by 2 into minus v cos theta. Minus because it retraces opposite direction. So minus n. Plus m by 2 into v dash. V dash is the velocity of this part in horizontal direction. So m cancels on both sides. And on solving, we get v dash is 3v cos theta. So this is the correct answer to this question. V dash is 3v cos theta. I hope now you understood how to solve this question by conservation of momentum along horizontal direction. So after this, let us take up question number 18. So in question number 18, we have object A and B. So we have two rings here. So one more slightly concentric circle. So in this case, we have a ring. Let us show in red color. So one ring here. Like this. And another ring here. Like this. So this is ring A and this is ring B. And we are given this angle. Angle here is 45 degrees. So in this case, we have two rings of masses m and m as shown, connected by light inextensible string. They are restricted to move along this ring of radius r in a vertical plane. The objects are released from rest. The tension in the cord just after release. We have to find the tension in the cord. Tension. What is the value of tension? If I consider this ring, so its one force will be mg, another force will be tension. So this ring, one force is tension, another force is mg. Let's resolve this mg. Suppose this angle is given as 45 as per the question. P cos 45. This is P sin 45. So doing force balance in vertical direction, we will have P sin 45 is equal to mg. So from this we will get P is equal to root 2 mg. So our correct answer to this question will be tension force is root 2 mg, which is option C. So the correct answer to question 18 is option C. P is equal to root 2 mg. Now in question 19, we are given some diagrams. So let us see the diagrams one by one. So we have three pulley systems like this. Now, in this case, we are having some springs here as shown. So we have some springs also. And we have some masses. Let us say this is 2 kg and 2 kg. Let us say this is 3 kg and 2 kg. And let us say this is 1 kg and 2 kg. So they are all attached to a ceiling. So in this case, we have to find x1, x2, and x3. x1 is the extension in springs. x1, x2, and x3. They are the extension in springs. So we have to find the relation between extensions. So let us first think about the forces. So here let us find the tension. The extension is given as by spring force Kx, which is equal to tension in all three cases. Spring force is equal to spring force in all three cases. Because the spring and strings are attached, there is only one string throughout. The tension in one string is constant. And the tension force will be equal to spring force. So the concept involved here is this. Tension is equal to Kx. So whichever spring has highest tension will have highest extension. So in effect, we have to find the value of tension. Whose value of tension is greater, that will have more extension. So let us find the tension in each case. So T1, T2, T3 in three situations. So this is 2G. Here we have 2G. Here we have 2G. Let us also consider the accelerations. Let us say this has an acceleration A1, A2, and A3. So in this case, this is 3G force, this is 1G force, this is 2G force. And this is tension T1 again. So let us consider the acceleration in each case. Let us consider this acceleration as A in upward direction. So this will have acceleration A in downward direction, A1. So this has acceleration A2, this has acceleration A2. This has acceleration A3, this has acceleration A3. So these are the three cases which we have here. These are three cases. So let us try to find the value of tension force. So what will be the equation for first one? Let us see. First equation here is T1 minus 2G is to A1. So T1 minus 2G is to A1. And for this mass here, we have 2G minus T1 is to A1. So from this, we will get the equation. In this case, on solving, I want to find the value of tension. So 2G minus T1 is T1 minus 2G. So 2T1 equals 4G. So T1 is 2G. So T1 comes out to be in this case 2G. So in first case, we have T1 as 2G. Second case, let us try to find the value of tension. So T2 minus 2G is equal to 2A2. Here we have 3G minus T2 is 3A2. So if I consider these two equations, let us substitute the value of A2 here. So 3G minus T2 is 3A2, which is T2 minus 2G upon T. So we have 6G minus 2T2 is 3T2 minus 6G. So we have 5T2 is equal to 12G. So tension T2 here comes out to be 12G by 5. So in this case, we can see T2 is greater than T1. So from these two equations, T2 is greater than T1. So X2 is greater than X1 as well. So X2 is greater than X1. Similarly, let us do the equation here. So here we will have 2G minus T3 is equal to 2A3. Here we will have T3 minus 1G is 1A3. So 2G minus T3, which is G plus A3, is equal to 2A3. So 3A3 is equal to G. So A3 is G by 3. So P3 comes out to be G plus G by 3. So P3 is 4G by 3. So now if I compare this 4G by 3 is the smallest. See, P1 came out to be 2G, P2 came out to be 12G by 5, P3 came out to be 4G by 3. So this is something like 1.33G. This is something like 2.4G. So which one tension is the greatest? 2.4. So we can say P2 is greater than T1, which is greater than P3. So X2 is greater than X1. X2 is greater than X1, which is greater than X3. So we can say from this X2 is greater than X1, which is greater than X3. So this is the equation answer which we'll get. So the correct option is option B, X2 greater than X1 greater than X3. So the correct answer to this question is finding tension normally. So whichever string has greater tension, that will have maximum spring force and maximum extension in the spring. So that is the concept. So after this, let us take question number 20. So in question number 20, we have a pulley and we have some strings here. And we have this. Here we have a force which is M2G. And we have M1 mass. So this force is M2G here. We have to find the acceleration of M1. So let us try to find the acceleration of M1. So in question number 20, we have to find the acceleration of M1. Let us try to find. So this force is M2G. So here tension force will also be equal to M2G because force in one string is constant. Tension in one string is constant. So this will be the direction of acceleration. So we can say big force minus small force is mass into acceleration. So in this case, big force is upward force because acceleration is upward. So P minus M1G is M1A. But the value of P we have found is M2G. So M2G minus M1G is M1A. So our answer for acceleration, it will come out to be M2 minus M1 upon M1 into G. So this is how we will solve the questions of Newton's laws of motion. So after this, let us move on to next section of the sheet, which is JE archives. So after this, let us see JE archive questions. So next, we are taking JE archives of our class notes, which is page number 99. In page 99 of our class notes, we have JE archives. So first, let us solve JE mains questions. So first question of JE mains, let us take one by one. So in this case, the first question we have, in this case, a mass of 10 kg suspended vertically by a rope from the roof. That is a roof. And a mass of 10 kg is suspended. So when a horizontal force is applied, F, let us say, is applied, the rope is deviated by an angle of 45 degrees. When horizontal force is applied, the rope is deviated by 45 degrees. So 10G force in downward direction, force F here, and tension force P here. So let us take the components of this tension force. This is 45 degrees. This is P cos 45. This is P sin 45. In horizontal direction, we can say P cos 45 is F, and in vertical direction, we can say P cos 45 is 10G. Let us first write vertical direction. P cos 45 is equal to 10G. And let us then take horizontal direction. T sine 45 is equal to F. So in this case, we have to find the magnitude of F. So first let us find T from here. So from vertical equation, we get T is equal to 100 upon cos 45. So 100 upon 1 by root 2. So 100 root 2. So T value is 100 root 2. Let us substitute this value of T, 100 root 2, in equation for horizontal. So horizontal equation is T sine 45 is F. So F comes out to be T value, which is 100 root 2 into sine 45, which is 1 upon root 2. Root 2 cancels. And we get the value of F as 100 Newton. So the correct answer to this question is F is 100 Newton. So this was question 1, option B. Now let us go to question 2. So we have a particle of mass m, which is moving in a straight line with a momentum p. Starting at time 0, that time 0 of force acts, which is kt, in the same direction. So this force changes the momentum from 3p to p. So changing momentum is 2p. Now force is dt by dt. We know this. We have to find the value of time in which this momentum changes. So force is dt by dt. So kt is equal to 2p upon time, which is t. So in this case, we have to find the value of t. Let us not write like this. Let us write it in derivative form itself. So cross multiplying. So after this, let us integrate it. So integration of this is integration of this. So initial momentum p to 3p times 0 to capital T. So k into capital T is equal to 3p minus p. So 2p is equal to kt. So p comes out to be 2p upon k. So the correct answer to this question is time comes out to be 2p upon k. I think I did some mistakes, slight mistake here. Integration, I did a mistake. Let me rectify. The integration of t will be t square by 2. This is t square by 2. So this 2 and 2 multiplies to give 4 here. We'll have 4 here. And there will be t square here. So our answer will come out to be t is equal to square root of 4, which is 2, times square root of p by 2. So our correct answer to this question will be this. Time t is equal to 2 times square root of p by 2. This is the correct answer. Here I forgot to do the integration. Integration of t is t square by 2. Okay. So this is how we solve this question number 2. So let us move on to question number 3. So in question number 3, we have a spring. We have a spring whose unstretched length is L. It has a force constant K. Now it is broken into 2 parts. So first part has length L1, second part has length L2. And let us say K1 is the spring constant of first part, K2 is the spring constant of second part. Now we know spring force is Kx. Also we know for springs, spring constant is inversely proportional to length. We know this, we have seen this in spring forces. So we can say K into L is a constant. So we can say KL is K1L1 is equal to K2L2. Now the question we are asked, ratio of K1 upon K2. So K1 upon K2 will to L2 upon L1. And according to the question, we have L1 is N L2. So L2 upon L1 will be 1 by N. So K1 upon K2 comes out to be 1 by N. So our answer to this question, K1 upon K2, it comes out to be 1 by N, which corresponds to option C, which is the correct answer. So the JEE third question is option C, 1 by N. Now let us move on to fourth question. In the fourth question, we have a mass of 10 kg, which is suspended from a rope. So this is 10 kg mass. This is suspended from a 4-meter long rope. A force F is applied horizontally at a midpoint of the rope to take the half. So this somewhere we have a force F here, and this mass M of 10 kg, it moves making an angle 45 degrees. So again, if I draw the free body diagram in this new position, so 10G force acts in downward direction, F acts here and tension acts here. Because this angle is 45 degree, so this will be T cos 45, this will be T sin 45. So equating the forces in horizontal and vertical direction again, so we have T sin 45 is F and T cos 45 is 10G. So along horizontal direction, we have T sin 45. Sorry, along vertical direction, let us write in red color. Along vertical direction, we have T cos 45 is equal to 10G. And along vertical direction, horizontal direction, we have T sin 45 is equal to F. So if I divide these two equations, I will get cot 45 is equal to 100 upon F. So F comes out to be 100 Newton again. So our answer to this question is F is 100 Newton. If you see carefully, JEE Mains 2020 and JEE Mains 2019 question were one and the same itself. They are repeat questions. So exactly same questions if you see carefully, except 4-meter length, which is useless in this case. So our option will be option A, which is in this case 100 Newton. So that is how we solve this JEE Mains question. So after these JEE Mains questions, let us move on to JEE Advanced question. Let us see JEE Advanced questions of the year 2009-2014 based on this topic of Newton's laws of motion. So first question we have is, a piece of wire is bent in the shape of a parabola. Y is equal to kx square. So this is a parabola, something like this. Y is equal to kx square. So there is a bead on it. The bead can slide without friction. It is initially at the lowest point where the wire is at rest. The wire is now accelerated parallel to itself, parallel to x-axis with acceleration a. So the bead will have a pseudo force and it will move somewhere here. So in this case, we have to find the distance of the new equilibrium position of the bead from the y-axis. That means we have to find the x coordinate of the bead. So let us see how to solve this question. So let us think about the forces acting. This is the parabola. This is the bead here. One force is mg, another force is normal reaction. Then let us consider the angle here. So the angle with the vertical, let us consider theta. So this will be n cos theta. Horizontal component will be n sin theta. Pseudo force will be ma, opposite to direction of acceleration. Acceleration is rightward. Pseudo force will be in backward direction. So let us now equate the forces in vertical direction and horizontal direction one by one. So n cos theta in this case comes out to be mg, and n sin theta comes out to be equal to ma. So first let us write horizontal equation. N sin theta is equal to ma. Then the vertical equation, n cos theta is equal to n sin theta, sorry. N cos theta is equal to mg. And if I divide these two equations, nn cancels, cancels, and I get tan theta is a by g. But by derivative, we know tan theta is dy by dx, where theta is the angle made by the line with positive x-axis. Suppose I draw a tangent here at this point of the bead, the new equilibrium point of the bead. The tangent will look something like this. And this tangent will make an angle theta in this case. So hence we have tan theta is dy by dx. So considering that, dy by dx comes out to be equal to a upon g. But we have this y is equal to kx square, so dy by dx is nothing but a times 2x. By using the formula of derivative, dy by dx is k into 2x. So let us write dy by dx is 2kx. So from this, the value of x we will get as a upon, so value of x comes out to be a upon 2gk. So the final answer to this question is x, which is the x coordinate which we have to find, a upon 2gk, which corresponds to option B. So the correct answer to this JEE advanced question is option B. X is a upon 2gk. So now some might be concerned with the angle. So angle between two lines is angle between the perpendiculars. Angle between this line and this line is angle between this line and this line. So this is theta. And someone might think this is 180 minus theta, we should actually take. So tan of 180 minus theta we can find. So only thing which we have to consider here is this magnitude. So x coordinate magnitude will be a upon 2gk. It will be negative value. So that is how we solve this question, JEE Advanced 2009. Now let us solve JEE Advanced 2014 question. So in it we have a semicircle, something like this. And in this case, we have a semicircle here, something like a semicircle. And here we have a bead. This bead goes from top to down. A wire which passes through the hole in a small bead is bent in the form of a quarter circle. The wire is fixed vertically on ground as shown in the figure. The bead is released from near the top and it slides along the wire without friction. As the bead goes from A to B, the force applied on the wire is. So we have to find the direction of force. So let us take this position, some position here, some position here. So at these positions, we have to find the direction of force. So that means normal reaction. So let us consider this point. Normal reaction is like this. And we will have a force mg in vertically downward direction. And we will also have the acceleration. So let us take some point here for better understanding. Normal reaction is like this. And this is mg. This is acceleration, which is v square by r, because it is circular motion. So in this case, we will have a component of mg. So let us take this angle as theta. So this will be mg cos theta. And this is acceleration v square by r. So the forces acting on the bead are normal reaction, mg cos theta, and acceleration is towards the center, which is v square by r, centripetal acceleration. So equation will be n minus mg cos theta is mv square by r. Big force minus small force is mass into acceleration. So this is the equation. Sorry, it will be the other way around. Acceleration is towards the center. So equation will be mg cos theta minus m. So mg cos theta minus m, because this is big force mg cos theta. Acceleration is towards downward direction. So this is our equation. Now by energy conservation, between the top point A and P is this point. So if I consider energy conservation at A and P, so this height traversed, we can prove, we have proved many times in circular motion, it is r minus r cos theta, because this whole distance is r and this distance here is r cos theta. So our height in this case will be r minus r cos theta. So if I apply energy conservation at A and P, we will have, in this case, loss of potential energy is equal to gain in kinetic energy. So the loss of potential energy is equal to gain in kinetic energy. So mg into height lost, h value is r minus r cos theta, because total distance is r and this is r cos theta, so this will be r minus r cos theta. You can easily prove by geometry. We have done this in circular motion. So that will be half mv square. So v comes out to be cancels, root of 2gr into 1 minus cos theta. So this is the value of velocity. Let us substitute this value of velocity in this expression and find normal reaction. So normal reaction comes out to be, in this case, mg cos theta minus mv square by r. So the expression for normal reaction is mg cos theta minus m by r into v square, which is 2gr into 1 minus cos theta. Let us write the expression for normal reaction. Let me write this part. So from this normal reaction, we can get as n normal reaction minus equals mg cos theta minus mv square by r. Let us substitute this value of v here. So n comes out to be mg cos theta minus m by r into v square is 2gr into 1 minus cos theta. R cancels and we get 2mg into 1 minus cos theta. So on simplifying, we'll get the value of normal reaction n as mg into 3 cos theta minus 2. So this is what is our function for normal reaction. This is the value of normal reaction. Now if you see carefully, this normal reaction can be positive, can be negative, because we have this term here. What is the term which we have here? Normal reaction depends on this 3 cos theta minus 2. This quantity can be positive or negative. So 3 cos theta minus 2 can be positive, 3 cos theta minus 2 can be negative. If 3 cos theta by 2 is positive, then cos theta is greater than 2 by 3. And if 3 cos theta minus 2 is less than 0, then cos theta is less than 2 by 3. So the direction of normal reaction will depend on whether cos theta is less than 2 by 3 or greater than 2 by 3. So in this case, we can have radially inward and radially outward, both directions are possible. So on analyzing this geometrically, cos theta less than 3 by 2, cos theta greater than 2 by 3. So we can get the correct answer to this question is option B. Radially inwards initially and radially outwards later. So that is how we'll find this. And we can find this by easy way as well. So in this case, we have mg force here. At this point, normal reaction is something like this. So in this case, we can find initially the answer is radially inwards, and then later on it is radially outward direction. So as we go from A to B, depending on this value, cos theta greater than 2 by 3 or cos theta less than 2 by 3, our normal reaction will be initially radially inward and later on radially outward. So the correct answer is option D, and that completes the JEE archive questions. So I hope you understood this concept carefully and solved all the questions of JEE archives of laws of motion chapter. Do practice more and more questions and perfect this topic of laws of motion without friction.